Hello, welcome to my talk, Editor Scripting the Scene View. I am Oliver Eberlei, and I'm going to present you some ways where you can improve your productivity, or where you can create tools for your team or for yourself, so your level design might go smoother. So, yeah, editor scripting is really one of my favorite topics to talk about. It's a huge area in Unity. There are so many different ways you can script the editor and change the editor to your will. And we're going to talk about a specific one. So first things first, the assets, the demo project that I made for this talk will be available next week ish on letscodegames.com. Just so you know, you can get all the code and look at it later. So, what is editor scripting? The Unity manual quite cryptically says, Unity lets you extend the editor with your own custom inspectors and editor windows, and you can define how properties are displayed in the inspector with custom property drawers, which is, I think, not a very good explanation, but what it actually means is, so custom inspectors means in the inspector, your components can have a custom view, like in the top left. For example, in this example script, you have a damage and an armor script, and you have these nice visualizations of the damage and armor values there. And it's easier to visualize stuff. It's easier to make the editors in such a way so you can edit and control your data better. You can create your own windows, just like the project window or the scene view window or any other window in Unity. You can create your own. So, for example, I often have a window in my projects that has kind of a game prefs set up, so I can set up some basic game variables it really depends on the project, but yeah, you can have your own windows, and they are dockable just like any other Unity window itself. So it's very easy to position them in such a way so you can work very, very easily with them. Custom property drawers are a super interesting thing where you can, if you have a data type that you use very often, in this case, for example, at the very bottom here, you can see the turn rate. The turn rate is just the float value in the script. You see it on the left side. That's before the property drawers were applied. But the turn rate, sometimes these float values have a specific meaning. They can only be between 0 and 100, for example, or they mean something to your game that Unity cannot decipher on its own. So you can create a custom property draw, so whatever is drawn in the inspector fits much better the data that you have, and you can edit them much more easily. And you can also work with handles. Handles are really stuff that you can draw in the scene view. So the position and the rotation handle, the default handles by Unity, you know them quite well. But you can also do your own. And that's what we're going to talk about today. So editor scripting is sometimes really hard to learn because the resources. So there's the manual by Unity and the scripting API, of course, but that's pretty scattered and hard to get through, or it's hard to know where to start. And you have a bunch of tutorials online. You have actually a bunch of tutorials on the Unity YouTube channel. So if you search for editor scripting on the Unity YouTube channel, you see a bunch of videos. And the top 2 videos, actually, are talks that I did over the last 4 years. So as I said before, editor scripting is my favorite topic to talk about. So I talk about it every other year, it seems, at Unite. So if you want to learn about how to write custom inspectors and stuff like that, the 2016 talk is pretty good for that. And if you want to get an overview of what editor scripting can do, in the 2014 talk, I show you basically my actual game projects, and what kind of editor scripts I did in them. So that's basically just a pile of nuggets, and hopefully there's something there that you can take home. But as I said, I talk about editor scripting a lot. So about me, I'm Oliver, and I'm using Unity since 3.5. So for over 8 years now. I'm an indie developer since 2011 with my studio Hammer Labs. I do Unity tutorials on and off on YouTube, the channel Let's Code Games. And I'm a VR developer since 2015. You can see it on the photo. I actually have my Vive Pre there. I was able to work on a launch title for the Vive. And if you just indulge me for a minute here, the Holocafé that I'm working on right now, my current project, that's actually a VR arcade, and also we develop our own games. So I just want to show you a minute what we do there, and then we can jump into editor scripts. And so the Holocafé, as I said, is a VR arcade. We develop our own location-based VR games, but what makes it special is they are local multiplayer VR games. So we have 4 people using the Vive at the same time together. So yeah, so it's quite frantic. It's quite fun to have 4 players in VR at the same time, and we have multiple locations in Germany, and we're expanding in the future as well. So if you're into VR and multiplayer stuff, you can also come talk to me later. It's quite fun. Okay, back to editor scripting. Let's talk about handles. Handles, as I said before, like the position handle and the rotation handle and everything that Unity provides us are those are the basic methods that we can interact with objects. But interaction can be so much more complex than that. So, for example, if you work with the Unity terrain before. You have this, you can draw on the terrain, you can draw the atlas map, the splat maps, so you have different textures blended together on the terrain, and that's also done using handles, the way you can draw on the terrain. And I mean, now with 2018, we have ProBuilder for free in Unity, and ProBuilder is basically just an explosion of editor scripting, so everything done there is editor scripting. And the cool part is that Unity's editor scripts are actually open for us to read. So back in, I'm not quite sure, a couple months ago, Unity actually open sourced all their C# source code, and you can look at it on GitHub and see how all the editors that they wrote, how they work and how they wrote them. And that's actually one of the best resources to learn about this stuff, because everything that you can do in Unity, everything that's possible in the editor, is actually done with the same tools that you have available. So you could, if you wanted to, recreate the whole Unity editor interface, at least, and functionality by yourself and rewriting everything and maybe improving upon it. And I have a link to the GitHub repository at the last slide, so that is a super useful resource. Okay, so a couple of weeks ago, I was thinking about how to do this talk and how to show what handles can do and how powerful they are. And I think it was a week or 2 weeks back, there was this awesome tweet that I saw by someone who said, I made a Pong in the Unity editor. So that's the Unity inspector, custom inspector that plays Pong. And I like everything about this video. I mean, especially, it's using editor scripting in a very useless way, and I like that. The actual script is called Procrastinate, which is amazing. So I thought, okay, great. This is actually a cool idea to show off what editor scripts can do. So I made a small, let's call it a handles game jam, and tried to make a game that's only done using handles. So this is Unity. You know it quite well. This is an empty scene. So I want you to note that what I'm about to show you, I'm not touching the play button. And also, the hierarchy on the left side is completely empty, right? So there are no game objects, no particle systems from Unity whatsoever in this scene. So it looks like a quite like the default view of Unity, but in the top left corner here, you see this small button. And once I press this, my editor scripting game is being shown. And actually what I tried to recreate was the game missile command from the old arcades. So again, nothing in the hierarchy. We haven't pressed play at all. And we have a couple of different things we can see here. So the green circle is basically the play space where everything is going to happen. The cyan cylinders here are supposed to represent buildings. I mean, I'm a coder, so this is programmer art, obviously. And on the four red cubes here are actually our turrets. And what we can do with our turrets is, before I start the game, so we have this fancy arc handle that I'm going to show you how to do a little bit later. So we can have an angle that we can set up. We can also rotate the cubes using this disk handle here. And then when I press the cube, a missile is firing with a nice little particle effect there. I mean, whenever you don't have a particle system and you're a coder, you have the urge of writing your own particle system. So that's what I did using handles. This is a handle particle system. Not very useful, obviously, but it looks cool. Yeah, and when I press start game, actually my city is being attacked by all these missiles, and I have to try to line up my turrets in such a way so I can shoot them down before they touch the ground. Yeah. Again, super useless, but fun. And you can learn quite a lot about, or actually I learned quite a lot about handles and what they're able to do. Oops, okay, well, I'm going to lose here, but that's fine. So let's talk about all the different aspects that went into making this game. So I try to, for every component in this game, I try to use a different handle, a different way to achieve this. So in the end, I ended up with all these different tools that I can show you and hopefully teach you something new that you didn't know before. Okay, let's start with the simplest handle that we can have. So handles are actually being used. So I will talk about how I made this game later if we have some time. But here I'm going to show you how you're actually supposed to use handles. So this is a capsule. And when I click on it, it actually says the position of the capsule below it. This is one of the most basic ways you can use handles to just have a text in this 3D scene view. So you have some game data there that you need visible at all times, and stuff like that, for example. The script for this is actually completely empty because it's an editor script, but we need a component to actually draw handles, right? So just like editor scripts, you have like for the inspector, the handles are also scripts that are drawn for a component. So if you go in the editor folder here, the editor folder is actually quite special. The name is special because everything that is in the editor folder is being compiled into a different assembly that Unity only accesses when you are using the editor. So everything you do in here will not be available to you at runtime, which is helpful if you have editor scripts. You can have debug stuff in there, hacking stuff in there, just so you can make your game more quickly. And you don't have to worry about this code ending up in your runtime. Okay, so let's go. So this script is the label demo. So let's go to the label demo editor here. And oops, I wanted to change this beforehand. Let's make this a little bit bigger. All right, there you go. Okay, I have no idea why Visual Studio is marking everything here, but it works. We saw it before, so fine. We just deal with it. So this is the editor script for the label, and basically instead of when you do, if you know how to do regular inspectors, you basically have this function on inspector GUI here, and you can draw stuff like this, and then basically for my oh well, I'm sure I mistyped this. So something like this, actually. So on inspector GUI or something like that, you're going to need to have your script show up here in the inspector. But to have something show up in the scene view, you actually use the callback on Scene Gui, and this is to handle scene view events. You can not only handle repaint events in here so to draw stuff, you can also handle mouse down events or keyboard events. If you want your script to be able to have some shortcuts, something, you can do that here as well. Okay, the handles. I'm actually quite annoyed that the assemblies are not loading here. 1 second. Let's restart Visual Studio. So to draw a handle, you're using the handles class that is in the Unity editor assembly. So the first thing that you do is you're at the very top, you're importing the Unity editor assembly, and then you can use the handles class. In this case, we're using the label component. It asks us for a position where it's supposed to draw the label, and then it asks us for a string, whatever we need to draw. So in this case, we're simply passing the position in here and casting it to a string to draw this. So one of the simplest ways to have code or any debug data show up in the scene view. So let's go on a little bit and see how we can make GUI elements. So in the scene view, we can actually have all the regular GUI elements that you can draw in the inspector. You can have them show up here as well. So as you can see here, when I click down on the script and my GUI demo component is attached, it actually draws this little GUI here. And when I change the slider, you can see here that the test value that I have here is actually changing from 0 to 10. And when I press hello world, it prints out a hello world statement. So whatever you are able to do in the with GUI components, you can also do that in the scene view. Quite simply, by declaring that you want to draw a GUI using handles.beginGUI, and then you can use all the GUI or GUI layout components that you know, or even editor GUI layout that you know from inspector classes and other GUI classes. I use the horizontal slider here, for example. I have the button here. So quite simple stuff. But it is useful to sometimes have GUI stuff in the scene view right next to your object, so you can really see and compare what happens when you change values and stuff like that. Okay, moving on. So in this scene, I have, well, you have to use your imagination here, but this is supposed to be a door, right? And when I click on this door, I have these two shapes show up, and they only show up when the door is active, of course. And they have a hover state, so it seems like I can press on them, and they are actually buttons. So in this case, I can press the green button to open the door, and the red button to close the door. So that's obviously quite useful if you have a bigger level and you have certain states that you need to check out for your objects, you can simply have these labels, these buttons here, and switch between the different states of your objects and see how they change within your scene. So for this, the script itself, the component actually simply has two simple methods, the open door and closed door, and basically the only thing that I do is rotate the door in this case. But you can imagine much more complex behavior in here. And then for the editor script, I simply use the handles.button .button class. This also takes a position where it's supposed to be drawn. You can also have a rotation, since these are 3D objects. This function takes a size, how big it's supposed to draw, and then also a click size. So you can have a bigger object and also only have it you're only able to click on it in the center, for example. I'm actually not quite sure why you want that, but there you go, you can have that. And then also you can pass on a cap function. And cap functions are something that come up in editor scripts quite often. Basically, in this case, this is a cube handle cap, and you can imagine the caps if you think about the default handle here. So the movement tool, for example, they have arrow caps, right? If I switch over to the scale tool, now I have cube caps. So that's basically just what is the endpoint, the thing that you click. That's a cap and a handle, and you can pass on. You can create a movement handle, but have a different cap in there, so it looks differently. Okay. So in this case, we use the cube handle cap. We don't have any lines around that, so basically that just means draw a cube. And since this is passed into the handles button method here, basically the cube is now clickable, and we can simply have an if condition around it. So if this button is clicked, then we want to open the door, and if the red, in this case, we use a red sphere. If we click this, then we call the closed door method. Great. That's the next thing is sometimes we want to draw debug data into the scene. Maybe you know about gizmos, you can use those as well, but handles is also a way to draw debug data into the scene. So in this case, we have a capsule again, and the capsule in the hierarchy has 4 different waypoints as children. And when I click on the capsule, the waypoints are actually visualized. So I have a line drawn here, and then the area the waypoints make is also being highlighted. So this is obviously useful if you want to have different areas in your scene where maybe you want to highlight your trigger volumes, or you have an area where there's danger, like a lava area, and the player always takes damage when they're in that area. This way you can visualize that area, and it's easier for you to see if everything is where it's supposed to be. When I click on the different waypoints here, it disappears though, because the component is actually only on the lines demo component here, which is on the parent of the waypoints. So that's a little bit annoying. So let's find a way, but we can move the waypoints like this and then go back. That is not very helpful. So let's see how we can improve upon that a little bit. The next scene, I have basically the same scene, but in addition to the... Oh, wait, no, I want to show you how I actually did the lines first, which is helpful. So the lines itself, again, an empty script, but the lines editor script is being done like this. So first of all, I iterate over all the children of the target that I have selected. So in our case, the 4 waypoints. I always get the previous one and the current one in this iteration cycle. and then I use handles.draw dotted line. It takes 2 positions, and then it takes a float value that basically determines how big the dots, the dashes are of the line. And so this is how the dotted lines are being drawn. And then the yellow transparent area is being drawn by using the draw AA convex polygon function. So it draws an anti-aliased convex polygon. And this simply takes a parameter like a vector 3 array of all the points, and then it draws a convex polygon between those points. Another thing that you can see here, handles has a color property. That's basically a static property for all handles that come after that. So in this case, I made the line color yellow, and then for the convex polygon, also making that yellow, but multiplying that by 0.2 for the alpha value, so it's a little bit transparent. Okay. So let's improve on our script a little bit, so we don't have to go into the waypoints every time we want to change the area here. So what's this one? So again, same scene, but when I click on the capture now, I have the lines demo script just like before on this component, but I also have the position handles demo script here. And the position handles demo basically draws a movement tool on each of the waypoints. So now I don't have to access the waypoints to change the position of these waypoints. I can simply do that for all waypoints that are visible here. So that's obviously much easier to use and edit. So it's quite simple to use the default Unity handles in a new way. So let's look at how we did that. So for the position handle script, it's a really simple handle script. Basically, we have handles.position handle. You can give it a position and a rotation, so how the 3 arrow handle is being drawn, in which direction, and where it's being drawn, and then it outputs the new vector from its position. So when I simply pass this on back into the child position, I can now move the children without having to select them. So that is quite handy. Okay. So let's go into some more complex handles. Let's open the arc handle. The arc handle is a class by Unity that is, well, they call it an intermediate control, basically. And I'll show you in a second how you can, wait, that's, great. 1 second. This is actually supposed to be the next scene. And this supposed to have this. Okay, so this is an arc handle. An arc handle visualizes an arc, and also it allows you to edit that arc. So you have an angle component that you can modify, and you can see here in the inspector it actually modifies the value, and also you have these radius handles that you can click and drag to actually change the radius of this. So you can imagine this, for example, if you have a stealth game and you use this to define the area where a camera can see the player. This is a quite visual way to do that, for example. Okay, so the arc handle, basically the script itself simply stores the values, the radius and the angle, and then the editor script has, first of all, it's using the intermediate Gui controls. So that's basically the intermediate Gui controls is basically just a pile of helper classes that Unity provided for you to use if you want to do some more advanced stuff that, but that's also quite common that you would. So, for example, if you imagine if you use working with a collider, the sphere collider or capture collider rather, and you press Shift, you see the handles, so you can change the capture collider quite easily. That is an intermediate GUI control, so you can use that for your scripts as well to easily change sphere colliders or sphere objects. Yeah, and the arc handle is one as well. So arc handle is simply a class that we instantiate on enable, and then we set up some default values. So basically, we just say that it's a red. It's supposed to be drawn in red, and then the center part has 0.2 opacity, so it's quite transparent. And then in the on Scene Gui, we need to do just a few things, but it's not too bad. So first of all, we set up the angle and the radius. So from our object, we get the values that we have stored in our objects and pass them on into the arc handle, so it's being drawn correctly. Then we using a new drawing scope. I will talk about that in a second. And in that drawing scope, we call draw handle. So now draw handle does everything for us, and it also saves the new values back in the arc handle angle and radius values. So after we are done with everything, we can save them back into our object, so these values are stored. The drawing scope is actually a helper method for handles. If you have much more complex handles that use parenting and different positioning and stuff like that, a drawing scope basically takes a matrix. In this case, a position, rotation, scale matrix. So like this one. So you can create a position, rotation, scale matrix simply by using the TRS, so translate, rotate, scale method, and passing on the position, rotation, and scale that you want to use. And then we pass that on into our drawing scope. So now, everything in these brackets is using this matrix as a base matrix. So if I draw, let's say, handles, we draw a line. And then we say the line starts at vector 3, 0, and it should end at vector 3 up. So basically just a line that has 1 unit tall and ends being drawn from 0 to 1. Once this compiles, you can see, well, the color's not quite good, but you can see this white line being drawn here. But since we set up this matrix here to the position and the rotation of our object, once the object moves, this line moves with the object, and once the object rotates, the line rotates as well. Right? So this is how a drawing scope gets useful if you have chains of children and you need to use them to draw your handles in relation to your object rotation and position. So you can simply use drawing scopes. All right. So this is how you can use the arc handle. Again, just a helper class that Unity provided, but it's actually quite hidden in these intermediate GUI controls. So I was quite surprised to find this actually in preparing this talk, because it's a very useful handle. Okay, so these are all the default, there are plenty more, but that's basically an overview how you use the default handles that Unity provides you. But you can obviously also write your own. So if we go into the next scene here, so we have the disk rotator handle. And the disk rotator handle is something that I coded myself. It's basically mimicking the rotate tool, but you can only rotate around one axis. You don't have, just like the rotate tool I have open right now here, you have, for the rotate tool, you have all 3 different axes. But for, go back to 0. But for my tool, this circle here, we simply have the one axis, and when I click on this, I can rotate this script, this cube around this one axis. For my turrets in the first game, quite useful because they only needed to rotate around this one axis, and so I don't have the visual clutter of all the other axes that I actually don't want to have. But that is not a tool that Unity provides by default, so we have to write this ourselves. So let's see how this is done. Again, the script has nothing. We are just using the handle script here. And in the handle script, it starts off quite simple. It gets a little bit more complex once I go into here, but it starts off quite simple. First of all, we create a control ID, and control IDs are Unity's way to identify the different handles, so it knows which one is which if you have multiple ones in the scene. So for this, you create a new control. You tell Unity, I have this new control that needs an ID. You give it a random value. So every class has this get hash code value. So that's basically a random value. Well, random is not the right word. You need random data, but it needs to be the same data every time. So the get hash code function of any script actually is quite useful for that. And then you tell it what type of control it is. In this case, it's a passive control, which means basically the focus type is only useful for keyboard components. So can it take keyboard focus? If you press tab a couple times, should it be able to focus that control? So you can see here, it has a keyboard one. The passive type is usually the one you go with when you have visual handles, like our rotator handle. Okay, so the disk rotator handle gets this ID, so we know which one it is, and we need that ID to be able to interact with the handle. So clicking on it and stuff like that, Unity needs an ID to know which object have I clicked on and stuff like that. So that's the control ID. Then we pass on a position and a rotation, so we draw it at the correct position, and then the size, the radius of the disk. So let's look at what this method is doing. Okay, so this is like 90 short lines is basically our whole rotator handle. And okay, so there are multiple steps here, and we can go through it one by one. I said in the beginning that the on-scene GUI function handles GUI events. And GUI events are, for example, repaint events. So every time the scene view is redrawn, on-scene GUI is called with the event type repaint, so we know now we need to draw stuff. But Unity's intermediate GUI is set up in such a way that the same, like on GUI is the same thing. The method is being called multiple different times, and each time it's supposed to do something else. So it's kind of a weird hacky system that Unity built there. I mean, it works quite well. You don't have to write 5 different functions for everything, but that's basically some hidden knowledge that you need to know in order to not get lost in GUI stuff. So let's start with the repaint event. So basically, when you're in on GUI or on scene GUI, on inspector GUI, anything on XYZ GUI, you always have the event current property. And this current event tells you what is going on at the moment. Is this a mouse down event? Is this a repaint event? Is this a layouting event? So we can use the event current. And then we get the event type for our control ID that we created previously. So we only want to know what event types we have for our own control, and not for everything else that's going on. So let's start with the repaint event, because that's similar to those that we did before. First of all, GUI has the property hot control, and that's basically just an ID, just like the control ID that we have before, and it tells us which control is currently being used, which control is active. So we check if our control is active, then we want to draw our stuff in a slightly a different way. Basically, we just want to change the color a little bit. So you can see here, it's not active right now, and once we're in there, it's been drawn in yellow. And yeah, so we just draw the arc here. We're going into these variables in a second. And And then basically we also have a different color if we are close to the event. So basically, just if we're over the handle and not clicked it yet, so we have a nice little mouse over effect. And then here we simply draw a circle cap. So that's the circle that we have here with whatever color we set up before in these handles color assignments here. Okay. So this is the repaint event. We basically just draw the circle. Depending on if we are near it with our mouse or not, we change the color a little bit. So nothing too specific here yet. Then we have the mouse down, mouse drag, and mouse up events. We also have a layout event, and layout is usually for you to set up stuff, and if you're using on Gui, then it can calculate, the Gui layout method, for example, calculates the layout where the different elements are supposed to be positioned in the layout event. We don't need to do anything in the layout event, so we simply draw. We simply pass on the layout event into the circle handle cap, because Unity's cap functions, they can handle layout events as well. So we simply pass that on so the circle cap can do its stuff. And then we also handle the mouse down, mouse drag, and mouse up events. That is something, I mean, we can just quickly go through here. I mean, this is very specific to this component that we have. So basically, let's start on mouse down. And mouse down, we simply save what the current mouse position is. And we save what the current rotation of the object at the start is. So we can use these two values in mouse move to calculate the new values. Okay, so in mouse drag, we are also using the current mouse position. We are adding the delta position from the mouse on top of that, and then we calculate the angle between the start rotation, or not calculate. Basically, we use the start rotation and we add the new rotation that we created from the mouse movement on top of that. So basically, we just take the difference of the start mouse position and the current mouse position, and the distance between those is the angle that we want to rotate the component. So very, very simple calculation here. And then on mouse up, we simply set up some default stuff that every component does. So we release our hot control. So we say we are no longer using the events. We use the current mouse up event. So the mouse up event is not being passed on to the scene view, and other scripts are using it as well. And this is an interesting one. I actually have no idea what it does, but it needs to be there. I found this because I actually browsed through the scripts for how Unity does their handles, and they use it. And I haven't figured out, because it's not documented in the API yet. So I haven't found out yet what it does, but it just needs to be there. So no harm, no foul, I guess. And I will figure that out in the next week, and actually put a comment in the code here that you can download, so you don't have to look it up yourself. Maybe I just ask someone in the sessions over here. Right, and that's actually the whole component. So we're drawing our stuff. We're handling the mouse events here and passing them on to the component and applying our rotation for this disk rotator. So this is a rather simple handle, of course, but you can imagine these being much more complex. As I said before, the terrain editor has a handle, and you can edit mesh data with handles and stuff like that. Okay, so these are the handles that I wanted to show you. There's one more thing that is not really a handle, but it's so useful that I just wanted to share this with you. And that's something that is also in the, just like the arc handle, this is an intermediate Gui control. And this control is the tree view. the simplest way to use a tree view is basically, I mean, you see it if you make a public array, like here, this materials array, that's basically what they have here. And so that's what the tree view is, right? And Unity provides you a way to do that quite easily. And also there's a way to search in here, so you can filter these events. So this it's quite useful for smaller lists. But there's another control component called the multi-column header that you can use with this tree view together, and then you get something like this. And this is amazing. This is, I mean, this does so much stuff for you. If you ever had a list, a complex list of stuff that you needed to sort in any way, this is the component for you. I mean, you can sort. You have the columns up here. You can set these up so you can sort them. You can sort by name or by value, whatever. Just like the tree view, you can have children of elements. You can drag and drop elements around, so you can simply click and drag and move it over here, and then you reparent them. And this is all functionality that Unity just provides you. You don't have to write that yourself. You can draw the handles here, the icons and stuff like that. And everything is completely custom. So each of these columns, you can define what is being drawn, how it's being drawn. So yeah, that is just basically a little nugget that I wanted to share with you that I found. The tree view component is explained quite well in the manual, actually. It is super complex. But this window that I have right here, and another example for an editor window actually, is basically these are the tree view examples. So when you search for a tree view and you go to the manual side, it actually gives you an example project with different tree view examples here, and these are the ones that I just shown you. So you can look how they're being done. The manual explains it quite well. It is too complex. I mean, you can basically just have a whole session just on the tree view because it's super, super complex, but it's also very, very powerful. So just in case you ever needed to have a list and you need to be able to reorder it, the tree view component and multi-header component is there for you. Okay, so here are some learning resources if you want to learn more about handles. So first of all, as I said before, Unity released their C# source code, which means all the handles, the terrain editor scripts, and stuff like that, everything is open for us to see and see how Unity has done it. And that is the best way to learn about editor scripting because the documentation is actually quite sparse. So simply going into the Unity source code, see how it's done, especially in the subfolder editor, mono, editor handles. You can see all the editor handles and how Unity did their own handles there. The Unity YouTube channel, as I said before, a very useful resource. There are many talks about editor scripting there. And then the scripting API itself gives you an overview of all the functions that you have. And that is my talk. Thank you for listening.